Welcome back. Today we're diving into one of aviation's biggest weather hazards, thunderstorms. Powerful, dramatic, and dangerous, they're not just clouds with lightning. In this first episode, we'll break down how thunderstorms form, their life cycle, and why they're so risky for pilots. Let's start with the basics. A thunderstorm is a convective weather system that includes lightning and thunder. It may also include rain, hail, turbulence, icing, and wind shear. Every thunderstorm starts with unstable air, moisture, and a lifting force. There are three main stages in the thunderstorm life cycle. Cumulus stage, updrafts dominate. Air is rising, moisture condenses into towering cumulus clouds. Mature stage, updrafts and downdrafts occur. This is the most violent phase: rain, hail, lightning, turbulence. Dissipating stage, downdrafts dominate, and the storm slowly loses strength. The mature stage is where the danger lies. Updrafts can exceed 6,000 feet per minute. Downdrafts can cause microbursts. Hail, wind shear, and severe turbulence are common. Pilots must avoid storms in this phase completely. Let's talk more about updrafts and downdrafts. Updrafts feed the storm with warm, moist air. Downdrafts are formed when rain-cooled air sinks rapidly. When downdrafts hit the ground and spread out, they create gust fronts and wind shear. Microbursts are one of the deadliest thunderstorm phenomena. A concentrated downdraft slams into the ground, then spreads horizontally at high speed. If encountered on approach or takeoff, a microburst can cause sudden loss of lift and control. Thunderstorms come in three types. Single-cell, short-lived, isolated storms. Multicell, a cluster of storms in various stages. Supercell, large, rotating storms with extreme wind, hail, and tornado potential. Supercells are the most dangerous. They have a rotating updraft called a mesocyclone. These storms can last for hours and extend over large areas. Fortunately, they're usually forecast and visible on radar. Even smaller multicell storms can be dangerous, especially if embedded in frontal systems or low visibility. Don't underestimate a storm just because it looks small or is listed as isolated in the forecast. Let's explore storm hazards in flight. Turbulence, often severe or extreme in and around CBS. Lightning, can strike even without precipitation. Icing, rapid and intense due to high moisture content. Hail, causes significant structural damage. Wind shear, especially near the surface or within gust fronts. Lightning can damage avionics, puncture fuselages, or temporarily blind pilots. While aircraft are designed to survive strikes, repeated hits are dangerous. Avoid flying near any active cell with lightning reports or observed activity. Radar use is essential. Onboard weather radar shows areas of precipitation intensity. Red or magenta returns equals danger zones. Always avoid by at least 20 nautical miles, especially downwind. Remember, radar can't see turbulence or clear air around the storm. Satellite imagery helps too. Infrared satellite shows cloud top temperatures, colder tops equals higher clouds equals more intense storms. Combine this with radar, METARs, and pilot reports for full situational awareness. On your pre-flight briefing, always look for TSRA, CB, VCTS in METARs or TAFs. SIGMETs for convective activity. PIREPs about turbulence or lightning. Radar loops to see storm movement and speed. Pilots should never plan to fly through or over a thunderstorm. Tops can reach FL 450 or higher, and going above is often not possible or safe. Lateral avoidance is your best defense. If you're en route and see towering cumulus building fast, assume it's a growing CB. Climb or turn away early. Once inside the convective system, your escape options shrink fast, and turbulence can become uncontrollable. Let's recap. Thunderstorms form from moisture, instability, and lift. They evolve through three stages. Mature stage is most hazardous. Hazards include turbulence, hail, lightning, icing, and wind shear. Use radar, satellite, and pilot reports to detect and avoid. Maintain safe distances, never cut it close. In the next episode, we'll go deeper into thunderstorm forecasting, detection, and avoidance strategies for real-world flying, day and night. See you in Meteorology number 32, Thunderstorms, Part 2.